I'm going to show you how to use the Excel Companion's Significance Testing Workbook to generate confidence intervals for sample means. I'm assuming that you already understand a few essential concepts. First, I'm assuming that you know how to use means to describe interval level variables. Second, I'm assuming you understand the foundations of inferential statistics, especially the concept of confidence intervals. This video is for people who already know what confidence intervals are and now want to learn how to generate them with Excel. It's easy to generate confidence intervals for sample means with the Excel Companion's Significance Testing Workbook. You can download this workbook from the Excel Companion's website. You just input a few values specific to the problem you're working on. The worksheet does the calculations and shows you the results. To generate a confidence interval for a sample mean, you input 5 values into the worksheet. 1, the confidence level. 2, the sample mean. 3, the sample size. 4, the assumption about standard deviation, that is, whether it's known or being estimated. And 5, the standard deviation. All the information you input should come from the problem you're working on. After you make your inputs, the worksheet shows you the confidence interval on a graph, reports its lower and upper bounds, gives you the margin of error, and shows you how it calculated all of these values. To see how it's done, let's work through a couple of examples.
All right, now we're doing a confidence interval of a sample mean problem. So I'm going to click over in the workbook to the confidence interval for a sample mean worksheet. And this example says that a simple random sample of 40 items resulted in a sample mean of 25. The population standard deviation is 5. A, what is the 95% confidence interval? And part B, at 95% confidence, what is the margin of error? So on the worksheet, we've got the confidence level at 95, so I will leave that the way it is. The problem tells us the sample mean is 25, so I will input 25 as the sample mean. The number of items is 40, so that's our sample size. And the problem does tell us the population standard deviation, so the population standard deviation is known, and the population standard deviation is 5. What is the 95% confidence interval? Well, we're looking at it here. Centers at 25, and it could be as low as 23.451 or as high as 26.549. So there's our 95% confidence interval. At 95% confidence, what is the margin of error? Now we can look down at the margin of error calculations. Because we have a known population standard deviation, the worksheet is going to use the normal distribution for the confidence interval and calculating the margin of error. And that margin of error we can see is 1.549. So the margin of error is the distance to the top of the interval as well as the distance to the bottom of the interval. All right, here's another confidence interval of a mean problem. This one reads, a recent GSS asks, how many days in the past 7 days have you felt sad? The 816 women who responded had a median of 1, mean of 1.81, and a standard deviation of 1.98. Part A, find a 95% confidence interval for the population mean for women. Let's go ahead and just do that now. In the confidence interval worksheet, the confidence level is already set at 95, so I will leave that the way it is. The sample mean is reported in the problem. The women had a mean of 1.81 days. The sample size, 816 women. Now here's something to take a look at. The worksheet asks whether the population standard deviation is known. It's not known in this case because it's reported to us in the problem. The standard deviation of 1.98 comes from this GSS sample. So the sample data is being used to estimate the population standard deviation. And this is the typical case. It's rare that you would know the population standard deviation. And we input the sample standard deviation, 1.98. With those inputs, we'll get the confidence interval. We can see it plotted here. The point estimate is the mean, 1.81. The lower bound of the 95% confidence interval is 1.674, and the upper bound is 1.946. So this range is the plausible range of the population parameter. So that would be for part B. To interpret the confidence interval, the confidence interval represents the range of plausible values of the population parameter, more specifically the range of values that allows us to be 95% confident that the interval contains the population parameter. Okay, one more example of confidence interval of a sample mean. This one reads, a GSS asks subjects, how long have you lived in the city, town, or community where you live now? The responses of 1,415 subjects in one survey had a median of 16 years, mean of 20.3, and standard deviation of 18.2. Got two subparts here. The first asks, do you think the responses are normally distributed in the population? This part doesn't require the worksheet. We just have to think about it. The answer is no. It's not. The responses in the population are not normally distributed. One clue is that the median is 16 years while the mean is 20.3 years. A normal distribution is symmetrical, so the median and mean of a normal distribution are the same. Here they're quite different. The mean is a little over 4 years higher than the median. If you just think about it as well, would you expect the length of time that people lived in a community to be normally distributed? That would mean center on the mean of 20 years and evenly distributed around 20 years? Probably not. Most people in the community probably live there only for a short period of time, with some people in the community living in the area for a very long period of time. So you wouldn't expect a value like that to be normally distributed in a population. Now let's look at the second part. This will require the worksheet. Construct a 99% confidence interval for the population mean. So we use our worksheet. The first item to input is the confidence level. It asks for a 99% confidence interval. So we will tell it to give us a 99% confidence interval. The sample mean comes from the problem. The sample mean is 20.3 years. We also get the sample size from the problem of 1,415 respondents. Is the population standard deviation known? No. The population, the standard deviation is estimated from the sample. The sample standard deviation is 18.2 years. Now we see our 99% confidence interval graphed. It centers at the sample mean, 20.3 years, but in its lower bound is 19.052 years, and its upper bound is 20.548 years. So the plausible range of values for the population mean is anywhere between 19.052 and 21.548.